500 years ago, the Aztec civilization in today's Mexico believed that the sun and all its power was sustained by blood from human sacrifice. Today, we know that the sun, along with all other stars, is powered by a reaction called nuclear fusion. If nuclear fusion can be replicated on Earth, it could provide virtually limitless clean, safe and affordable energy to meet the world's energy demand. Deep within the heart of our nearest star, the sun, a fiery dance is taking place. It's a dance of nuclear fusion, where tiny particles called atoms come together to form a new element. This process releases an enormous amount of energy, and it's this energy that gives the sun its power. The dance starts with the lightest of all elements, hydrogen. The immense pressure and heat in the sun's core cause hydrogen atoms to collide and fuse. This fusion results in the formation of a heavier element called helium and releases a neutron alongside a tremendous amount of energy in the form of light and heat. The energy travels through the sun's layers and eventually reaches the surface where it is released into space as light and heat, providing the energy that sustains life on Earth. The process of nuclear fusion has been happening for billions of years and will continue to happen for billions of years more, providing the energy that keeps our planet alive and warm. The opposite of nuclear fusion is nuclear fission. While fusion combines light atomic nuclei to form heavier ones and releases a large amount of energy in the process, fission splits the nucleus of a heavier atom into two or more smaller nuclei. During nuclear fission, a neutron collides with the nucleus of a heavy atom, such as uranium or plutonium, causing the nucleus to split into two or more smaller nuclei. This process releases energy in addition to additional neutrons that go on to split more nuclei, creating a chain reaction. We've been using nuclear fission to generate electricity on Earth for many decades now. Nuclear fusion, however, while much harder to achieve, has also been garnering the interest of scientists for many years, primarily because it's a much better energy source than nuclear fission for many reasons. As already mentioned, nuclear fusion is considered to be a more attractive energy source than nuclear fission. It also compares favorably to other sources of energy including fossil fuels, and even has some advantages of renewable sources of energy. Here's what makes nuclear fusion a terrific energy source. Nuclear fusion does not release harmful radiation and does not produce long-lived radioactive waste, and a meltdown at a fusion reactor is impossible. This is in contrast with nuclear fission, which comes bearing the risk of nuclear accidents such as the one that took place at 3 Mile Island, Pennsylvania in March 1979. The safe disposal of nuclear waste is also an ongoing challenge that inhibits the advancement of nuclear power. This is because the waste can remain radioactive for millions of years. Current methods for disposing off of nuclear waste include the use of steel cylinders as a radioactive shield, followed by deposition in potentially stable geologic formations. Current waste disposal methods, however, are still risky and can have disastrous ramifications for the environment if not managed correctly. Nuclear fusion relies on fuel that is plentiful and easily accessible. Deuterium can be cheaply extracted from seawater, while tritium can be produced from lithium, which is naturally abundant. This makes fusion a more sustainable energy source than fission, which relies on finite resources such as uranium and plutonium. It is thus expected that fusion should be able to meet the energy needs of humanity for millions of years to come. Nuclear fusion reactions release about 4 times more energy per unit mass than nuclear fission reactions, making it a more efficient energy source. In theory, just a few grams of deuterium and tritium, the heavy isotopes of hydrogen, can react to produce a terajoule of energy, the energy that one person in a developed country needs over 60 years. Given practically unlimited fuel availability and high energy density, nuclear fusion has the potential to be highly scalable and could theoretically be used to meet the energy needs of large swaths of the global population. Nuclear fusion does not produce materials that can be used in nuclear weapons, reducing the risk of the proliferation of nuclear weapons. Nuclear fusion does not produce greenhouse gases, unlike fossil fuels, which are a major contributor to climate change. Lastly, unlike renewable energy, which is heavily dependent on weather conditions such as the availability of sunlight for solar power and wind for wind power, fusion plants can operate continuously and supply consistent energy to the grid, regardless of the weather. Nuclear fusion is considered a promising energy source because it has the potential to be safe, sustainable, and efficient. However, it is difficult to achieve because it requires extremely high temperatures and pressures to overcome the electrostatic repulsion between positively charged nuclei and bring them close enough together to fuse. The Sun's immense gravity creates the perfect conditions for nuclear fusion to occur naturally. However, without that force, much higher temperatures are required to initiate the reaction. On Earth, scientists have to reach temperatures above 100 million degrees Celsius and exert intense pressure to fuse deuterium and tritium. Additionally, it is crucial to confine the plasma effectively in order to maintain the fusion reaction long enough to produce more power than is used to heat the plasma, resulting in a net power gain. It may sound simple, but has proven to be exceedingly challenging to execute in practice. Scientists and engineers around the world are continuously working to improve the confinement and stability of the plasma in order to achieve fusion energy. Although experiments have successfully achieved conditions that are very close to those required for fusion, further advancements in confinement properties and plasma stability are necessary. They are testing new materials and developing new technologies to reach this goal. Despite these challenges, however, significant progress has been made in recent years in the field of nuclear fusion, especially with the influx of large amounts of funds, including those from private investors like Bill Gates and Jeff Bezos. I strongly believe that nuclear fusion will become a reality. The only real question is how quickly. Follow me and subscribe to continue to learn about fusion energy and recent developments that are bringing us ever closer to making fusion power a reality. I write every day mostly on topics related to business, finance, economics and topics in science that affect us.